Question 7, we're looking at another rational equation. So again, with equations, you can multiply an equation by the least common denominator to get rid of fractions. But one of the first things I have to watch out for is notice how there's x in the denominator. X cannot represent 0. So one of the solutions we have to exclude would be um, we have to exclude 0. Because if you put a 0 for x, that creates a 0 in the denominator, and that's going to create a situation where it's not calculatable. It's going to get undefined. So we have to avoid 0 when solving this equation. Now, when it comes to the LCD, we have a 3, an x, and a 6. Now, remember, LCD is the same thing as least common multiple. So one of the things we can do is look at the different factors. 3 is a factor, x is a factor. Notice that 6 is made up of 2 times 3. So if we're doing the LCD, if you will, what we're seeing to get the LCD, you're looking at the different factors. So 3 is a factor that occurs here, here, and here. But what's the most 3's I need? Well, this only needed 1 3. This didn't need any 3's. This only needed 1 3. So I need at least a 3. When it comes to the 2, this doesn't need a 2, this doesn't need a 2, this just needs 1 2. So I need 1 2. And then with the x's, this doesn't need an x, this needs 1x, and this doesn't need any x's. So I need 1x at most. So again, when you do this, least common multiple, you're kind of looking for the the least needed as far as those go, or um, basically what we're looking at is most seen, which is interesting. So the most seen here was 1. As far as x3's go, there's the most x's I needed here was 1. The most x's I needed here was none. The most x's I needed here was 1. So when I do my least common denominator, the most seen in each individual spot was just 1 3. When it came to the 2, the most seen was there weren't any 2's here, there weren't any 2's here, there was 1 2 there, so the most seen was just 1 2. And then I need an x here, but I don't need any x's here or x there, so the most that was needed was just 1x. So if we put this all together, you can kind of see that 6x is our least common denominator. So what I can do in this problem is I can multiply each side by the least common denominator, which is a 6x. So I have a 1 over 3 and 6 over x. So I'm going to multiply this whole side by 6x. And then I'm going to multiply this other side by 6x. So I'm just going to use a dot over there. But since I have two terms here, I'm going to use parentheses. So the catch is when I multiply this 6x through, notice that this 3 is going to cancel. But notice how this 6 turns into a 2 and this x stays here. So really what I'm doing is bringing a 2x through to the first term. 2x times 1 is just going to be this 2x. So I'm not trying to muddy up my problem too much there. So when I multiply the 6x through, the 3 is going to cancel the 3 here and make this a 2. 2 times x, or 2x times 1 would be just 2x. Now I need to multiply the 6x not only through here, but also I have to multiply the 6x through this part. But notice how when I multiply the next part, these x's are going to cancel, which is going to leave me a 6 going to multiply through. 6 times 6 would be then this 36. On the right-hand side, when I multiply this 6 times 6x, notice how the 6 is going to cancel this 6 and just leave me an x. So 5 times x is going to give me then just 5x. So my new equation doesn't have any fractions in it. Now, since it's linear, what we want to do is get the x's on the same side of the equation. So I pick on the little guy. So to get rid of this 2x, I can subtract the 2x here as long as I subtract 2x over here to zero that out. So in turn, this turns into 36 over here, and 5x lose 2x, this is going to give me a 3x. So I'm going to rewrite this then. Well, 3x has to equal 36. Well, to get rid of the 3, I have to divide both sides by 3 to get x by itself. And 36 divided by 3, you may have to use a calculator, but I'm thinking 12. So 12 times 3 would be 36. So my solution is going to be 12. Or I can write it as a solution set. The solution set is 12. So either one of those are acceptable. X equals 12 or the solution set is 12. Notice how, again, we did not get 0, so there was not any what we call extraneous solutions. There was nothing to exclude because the only solution was 12, not 0. So we don't have to worry about throwing anything out.